This project is presented by Miswa, Sabiksha, Yashika, Raza, Sohail, Neha, Nirmiti, Himani, Unnati, Sanya, and Vineet Kaur.
Hello everyone. So our first topic is basics about classes. In this we are going to see what is a class, its types, and then with its we are going to see its properties. First we will see what is a class. Classes are user-defined data types that represent the state and behavior of an object. It includes functions, methods, variables, objects in it. Contains main methods, that is an entry point to our class, and it is basically a blueprint of an object, and it includes polymorphism, inheritance, base class, derived class, etc. Next we will see one type of class, that is a sealed class. The sealed class cannot be inherited, and it is used to restrict the properties. Sealed class is created using a sealed keyword, and access modifiers are not applied to sealed class. To access the sealed members, we must create an object of this class. If we are going to use any confidential information or confidential data in our program, so it would be preferable if we put it in the all the methods and variables inside the sealed class, others cannot access it, and we can prevent the spoiling the data, and it is secure, and it is also secured. The next is a static class. This class cannot be inherited, and we must use a static keyword to make a class a static class. And next, only static methods and static variables are used in this class, and it cannot be accessed by any non-static class. So this is all about the classes we saw.
Building a class. As we all know, the C hashtag is basically associated with class object along with its attributes and methods. A class is a blueprint for creating an object. Here we will take a real life example of a car as an object, and we will assign attribute as color, weight, and method as drive and brake. In this example given, we have created a class called as car, and we have assigned it an attribute called as color, and we have assigned a value to the attribute as red. Now we will create an object for this class. An object is created using the new keyword. In this example we have already created a class. Now we will create a main method. In the main method we will create an object named my object. Card my object equals to new object. Using this we will create an object of this class, and now we will create a console.write line for printing the values of the color on the screen. In this, the dot operator is used for accessing the specific members of the class. Now we will see an example of a simple class. In this example, we have used using system for inputting all the system libraries. In this, we have created two classes. First is class building, and second one is class building demo. In class building, we have assigned three attributes called as floor number, occupants, and area. In the second class building demo, we have created an instance of class building called as house. Both the classes are separate, but the both class can create an instance of the other class. When the house is created, the instance falls, and it can add values to the instance and use the value of the instance. And by using this, it will give a value to all the instances. And then we will use the console.write line for printing the output.
An abstract class is a special type of a class that cannot be instantiated, and an abstract class is designed to be inherited by subclasses that either implement or override its methods. Means the abstract classes are either partially implemented or not implemented at all. Properties of the abstract class. The abstract classes are declared using abstract keyword. If the base class method implementation is optional, then we can inherit two abstract classes. The methods inside these classes cannot be privated, and this class has only one subclass. Then the parser class. The parser class is special feature of C sharp. It provides a specific ability to implement the functionality of a single class into a multiple files, and these files are combined into a single class files when the application is compiled. Then the properties of a parser class. The parser class is created by using a parser keyword. If we seal a specific part of a parser class, then entire class will be sealed. Then inheritance cannot be applied. Then the classes that are written two classes into two class files are combined together at a runtime.
Class members. Fields and methods inside the class are often referred as the class members. Methods are generally a block of code or a statement that can be reused. It saves time as well as the memory. It provides better readability to the code as well as good structure to the code. The syntax of a method is, first we have to write the access modifier, after that the return type of the method, after that the name of the method should be specified, and if we want to pass the parameter, we can write the parameter. Inside the open and close curly bracket, we have to write the body of the method. In the example, we have created full throttle is the name of the method, public is the access modifier, and return type is void, which means method is not writing anything. Then inside the body we have written console.writeLine and passed the string as the parameter. Constructor are the special method to initialize the object. They are called when the object of the class is created. Important things about constructor is that constructor has the same name as a class name. It cannot be abstract, final or synchronized. Within a class we can create only one static constructor. Constructor doesn't have any return type, not even a void. The types of constructor include parameterized constructor, static constructor, default constructor and private constructor. In the code we have created a class car and we have initialized the variables. Then we have created a constructor of a class public car. If we wanted it as access as a private, we have to write the private keyword. If we want to pass the parameter, then it will become the parameterized constructor. If we wanted to call this constructor only once, then we can specify it as a static constructor. And inside this constructor, this is the default constructor, we are initializing the value model. Then in the main method we have created the object named as Ford, and we are using the object we are calling the constructor and printing the value of model which is specified inside the constructor.
Value types. So let's see what are value types. A structure is a value type. All the differences that are applicable to value types are also applicable to structures. So there are several examples of value types. They are built-in data types like integer, float, boolean, etc. So the next point is structures are stored on stack. Let's see it with an example. As we have declared int I is equal to 0. Here I and j are basically integers and they are structures. So they are value types. So how they are stored in memory? So what happens is the value type stores the value on the stack and they are declared. So what happens is the C1 reference object is created on the stack, whereas the actual object is created on the heap. Value types hold their value in the memory where they are declared. So in the program, as you can see, I and j are value types and they hold their memory where they are declared. Next is value types are destroyed immediately after the scope is lost. So in this program, as you can see, the I variable has a scope for the entire main method, whereas the j variable has scope only within the if block code. So what does this mean is the j variable will be destroyed before I, and then I will be destroyed. You copy a struct into another struct, a new copy of that struct is created, and modification done on one struct will not affect the value contained by the other struct. So when we say j is equal to I plus 10, here we have done a modification, but this modification will not affect the value of I, because when we copy value type, we get a copy of that object. Next is structures cannot have destructors. So we have destructors. Destructors will have same name as the class name with a tilde symbol. So as we know that structures cannot have destructors, when we build this program we get an error. Structures can have parameterized constructors, but they don't need to have explicit parameterless constructor. It actually makes sense because structures don't have the concept of object reference variable and object, so they don't need to have parameterless constructors and destructors. The next one is structures cannot inherit from class, but both class and structure can inherit from interface. Structures don't support implementation inheritance, but they do support interface inheritance.
So in computer programming, as Ms. Ba said, data types can be divided into two categories: value type and reference type. A value of value type is the actual value, and a value of reference type is a reference to another value. Then the variable of reference type store references to their data object, while variables of value type directly contain their data. With a reference type, two variables can reference the same object. Therefore, operations on one variable can affect the object referenced by the other variable. Then the example of reference type includes string, array, object of classes, etc. To create reference type in C#, you can take advantage of those keywords. Those are class, interface, and delegate. Then for example, if we define and assign a value to the one variable, which is a string name Neha, then the system will store the variable value Neha in one location, which is the heap, and the variable name in another location, which is the stack, along with their memory address of the variable value. Then let's see the introduction of the reference type. Then reference types do not store the data, then it will store a memory address, and that memory address contains the data. Then reference type memory is obtained from the heap, then it will store data in memory address of the variable itself. Also, reference type store a 32-bit and 64-bit pointer to another object, the variable reference of the object. Then for example, if we define and assign a value to the variable like string name equal to Neha, then the system will store the variable value Neha in one location and variable name in another location, along with their memory address of the variable value. And this one is the pictorial representation of the reference type. So let's see the another example of reference type. Consider a class as counter, then variable C will be created somewhere in a memory that will contain reference address of the value x, and that is the phi that is created somewhere else in the memory. So if we create another object, example counter C2 equal to C, then C2 will.
A delegate is a reference function that holds the reference of a class method. Any method which has the same signature as delegates can be assigned as the delegate. It is very similar to the function pointer, but with a difference that delegates are a safe type. We can say that it is the object-oriented implementation of function pointers. Some of the key points about delegates are that they allow methods to be passed as parameters. They are used in event handling for defining callback methods. Also, once a delegate is created, the method it is associated with will never change.
because they are obviously immutable in nature. Delegates delegate types are incompatible with each other. Even if their signatures are the same, they are considered as equal if they have the same number of references. Okay, same reference method. They can also be used to handle multiple methods on a single particular event. They can be used for decoupling and implementing generic behaviors.
Types of delegates. There are three types of delegates that are used in C#: single delegate, multicast delegate, and generic delegates. So let us learn about single cast delegate. Single cast delegates derive from the system delegate class. It is used to make a single method at a time. Syntax of this delegate is as follows: access modifier followed by a delegate return type, then a delegate name followed by a parameters. Single cast delegates have some of the features in C# as given below. We can pass the method as a parameter. It is transferred, and this is similar to C++ function pointer. It helps us to evoke and define the callback method. Next we have multicast delegates. Multicast delegates can be used to evoke multiple methods. The delegate can do multicasting, that is adding a new method on existing delegates using plus operator, and using minus operator it can remove a method from the delegate. All methods will evoke in sequence as they are assigned.
Today I'm going to explain generic delegates. Delegates defined with generic class can be used the generic class type parameters in the same way the class methods do. Generic delegates are especially useful in defining event based on typical design pattern because a sender argument can be strongly typed and no longer has to be casted to and fro from the object. So there are three types of generic delegates. First, function, second, action, and third, predicate. So I'll explain the three types of generic delegates a little more in detail. So the first generic delegate type is function delegate. So the function delegate defines a method that can be called on the arguments and returns a result. So the syntax would be of the function delegate, interest comma double is defined with the interest type as argument and double as a return type. So we'll go to the second delegate, which is defined a method that can be called on argument but doesn't return a result. So delegate action string is defined with the string as the argument. Third predicate delegate defines a method that can be called on arguments and always returns a boolean type of result. So in this type of delegate, that is the predicate delegate, the string, that is the check valid date, is defined with the string type as an argument and returns a boolean type result.
Event is nothing but communication between two objects via notification mechanism. Event and delegates are tightly coupled concept because event handling requires delegate implementations to dispatch event. How does it help? Event helps in building application in such a way that classes are not highly dependent on each other, which ultimately eases the tension of the app. Event enable a class or object to notify other classes or object when something of interest occurs. The class that sends the event is called the publisher, and the class that receives the event are called subscribers. In web form, a web application event can be raised by controls elements such as button or list box. Access modifier used in an event. Event can be public, private, protected internal, or protected private. These access modifier define how user of the class can access the event. Public. This type of member can be accessed by any other code in the same assembly. Private. This type of member can be accessed only by code in the same class or structure. Protected. This type of member can be accessed only by the code in the same class or in a derived class. Internal. This type of member can be accessed by any code in the same assembly but not from another. Protected. Internal. This type of member can be accessed by any code in the assembly in which it is declared. Private. Protected. This type of member can be accessed only within its declaring assembly by codes.
As explained by my co-presenter Sohail about how and why we use access modifiers in our events and delegates, further we will see different keywords we use while writing our events. Let's remember that we are using delegates to write our event, because delegates and events are couply linked together. So while writing an event, we use delegates. So first of all, one of the first keywords that we use is static. The static keyword is used to make it available to the caller at any time, even if it's not an instance of the class or if does not exist. Then the second keyword we use is virtual. Virtual keyword allows to derive class or override the event behavior by using override keyword. Then there is sealed. Sealed specifies that for derived class it is no longer virtual. And finally we use abstract class. The compiler will not generate the add and remove event accessor blocks, and therefore derived class must provide their own implementation. So to declare an event in a program, three steps are followed. These three steps are like, first, to declare a delegate. We need to create our first delegate. Then we need to create an event on that delegate. Then we need to publish the event. So for creating a delegate, we use delegate keyword. So it goes public delegate, then the name of the delegate, and we give our parenthesis. Then to declare an event for that delegate, we use public event and the name of the event that we want to give, which declares our event. Then we use the parenthesis and question mark symbol to publish our event inside the group, so that when a subscriber asks the publisher to give him some review on it or to take some action on it, it happens and it occurs